Well, thanks for raising the expectations. I first, lower them again a bit because what I'm presenting here are more or less concepts and ideas of ongoing efforts. So we are at Halfa Group. Christoph's here as well. We're currently building this content hub, and we're also here to learn from you. So if anybody of you has already built something like that, or thinks that your technology might relate it to our proposal, please talk to us. So, what's Halfa Group? You've probably not heard of us before, but in Germany we're actually quite popular among lawyers, people who work in taxes, people who do human resources. And we have, in fact, I think, Christopher, we have about 2 million customers in Germany, and our head office in the Black Forest, so it's also nice to visit. And we have 157 software developers. So, what are our roots? Our roots are books. Right, and if I browse through our catalog, sometimes it's really wild to see what kinds of books we have. But what actually our origins are loose leaf editions. So basically, like 50 years ago, we used to send a paper to lawyers, and they put it in folders. And once there was an update to laws being made, we sent them another piece of paper. And in the 1990s, we've actually started not to send them paper anymore, but CD-ROMs. And those CD-ROMs had databases on them. And guess what? Nowadays, the source of those documents is XML. So if you speak about Halfa today, we actually ship quite the same content to lawyers and tax people as well. But we do that using content databases. We have a large portal site that actually serves about 2 million page visits every year. Christopher built this. We have, I think, 3 or 4 years ago it's actually a long time, we've started to offer corporate trainings, and we have databases on our internet as well where people can book seminars and trainings. And well, guess what? We still do books. So speaking about the content of Halfa is we have about 50 million XML documents. And because the company started to do internet and electronic publishing in the 1990s, so these are, in fact, actually based in HTML, and we use an own set of DVDs to specify their structure. What we also have is we have an entire tool chain based on Python that allows us to transform that content to different target formats like PDF or database files or whatsoever. We have a lot of auxiliary content. We have PDFs, we have audiovisual content, we have forums, embedded applications. And our portal site has news posts, we have seminar descriptions. So there's quite a lot of different kinds of content formats floating around in that ecosystem. So if you look at that ecosystem, I've just shown you it's a tiny part of the main applications we have. But what you see up there is IDAS2, and IDAS2 is this content database mostly people like lawyers use to browse this data, and they mostly do that using text search. And it talks to a second system, that's a content retrieval system, and this is not a general name, in fact that's a real system, and it's a legacy system. It's a Python-based, SOAP-based database thingy that under the hood uses a C++ implemented search engine that is maintained by probably one developer on this planet, so if that one person, gets hit by a train, this is sort of difficult for a business. So this already shows that we have to do something about this. But it gets complicated, because IDAS does not use only CRS, it also uses L4. L4 is a secondary content database that allows a lot of stuff like retrieving similar documents. So that's actually what IDAS uses L4 for. But there's a second system, that's Halfa. It's a different content product, and it makes use of L4 for search, retrieval, and semantics. And speaking of Halfa DE, we have a third content management system used for search and retrieval, and it uses also L4 to retrieve similar documents. So, not complex enough. We start actually buying new companies like every 6 months. So then suddenly a new publisher comes into the house and say, okay, we have an own information ecosystem. We need to integrate that. And yeah, we have content. And can we not feed this somewhere in there? And at that point, it gets really strange. Because we of course, we want to reuse content among these systems. We want to cross-reference the content. in different databases. But how do you do that if you have inconsistent naming schemes? It's difficult to speak about authorization because one system has a totally different role model than another one. So how do you do that? We have massive content duplication because people start, well, okay, if you cannot deal with the upper two ones, we simply feed it to both systems. It won't work, you know. And this, of course, becomes costly because we have a lot of storage problems, and it does not really scale. And finally, of course, because I'm a systems person, I'm really looking at this ecosystem like, come on, guys, you're a publisher, you're not Google, and we've got probably like 50 technology stacks somewhere in the company. And this just leads to increased management efforts. So, in summary, what has happened is that we have come to this vision that we need somehow to bring these things closer together, and that we have to create a unified content hub. So, speaking of this, basically, it'll be made up using three different kinds of building blocks. And the first one, of course, is just a storage component. It'll be a database. The second one is search, because as I already mentioned, most people actually access our content using full-text search, so we certainly need to pull a powerful search engine for this. And finally, there's a triple store. What I didn't say so far is that our content is highly structured, and we want to make this structure accessible to the customers as well. I'll speak about this in a second. But what's actually the important take-home message is that we cannot actually assign those tasks to separate systems because they're highly interlinked. For instance, if you use the triple store to keep the structure how documents belong to products, and we want to filter a search based on this information, we need a tight integration of those two. And speaking about the integration of search and content storage, we certainly don't want customers to find documents that are not available in the database, and vice versa. And finally, of course, we also want the triple store to closely represent the structure of the content. So, what did we do? We created a layered architecture. That's what computer scientists do when they do architectures. And so how does it work? So basically what you see up there, I was just simply too lazy to put the systems up there. So what would be here are like the consuming systems, like IDS2, our portal sites, or future-based content products. And then on the bottom layer, we'll have content sources. And these content sources will be basically anything that delivers XML or even binary content to the content database. And what I call those are the sandwich layers. So in the middle, of course, we have the functional building blocks, search, we have content storage, we have the triple store. But what we build actually around this are sort of in sandwiches, they mirror each other. So we have authorization layers, of course, on top, because we need to make sure that consuming systems are, of course, just consuming content if they are allowed to. And similarly, we just want systems to deliver content to the database if they are allowed to as well. We need to do transformations on both sides, and of course, we might need to do transactions to ensure that content that is in the search is also in the store, and vice versa. And we might, on top, on the consumer side, need to aggregate this. Also important to keep on take home message, we have not built this yet. So we are currently in the planning stage of this. So what I don't need the umbrella. What's important here as well is that so far I didn't speak about why we need to need XPath and XQuery. It'll become obvious quite in a minute, because if you look at snippets of our code, basically what we have is that metadata is scattered all over the place. And if we would do this in the traditional way, we would need to extract the metadata and feed that to a relational database scheme. And this is it's actually not quite feasible because our structures are too complicated. So, why triples? What we see here are two products, Steueroffice and Steueroffice Gold. Those are actually real products we have in our store. And what I've just depicted here is some kind of content. And the way we actually relate content today to products are so-called construction plans. So construction plans are essentially XML documents, and they describe which content belongs to which Steuer office in this case. No, it's not a standardized technology. This is Haufe technology, so to say. And okay, but you know, at that point it's like, okay, certainly you don't need triples for this, but what's important is that this structure is actually arbitrarily recursive. So you might have construction plans including other construction plans and so on, and we actually don't know the depth of this tree. So, so it evolves into a graph structure, and it even does more so if we add a second product to this. Because products might include construction plans of other products, they might, of course, include additional content objects, and because we really want to make money, we have things that we have, you know, basic products that just include content up to a certain version. And if you have the gold, grayish product that includes the most recent version, we also have sort of, you know, connections in that graph that are expanded over time and make this graph so complex that we actually don't already know how it looks like. But let's go further. What's also, you know, what's also on the roadmap of our business people is that we want to build linked data applications. We want to interlink content with seminars we offer. So somebody reads a book or, you know, displays a document, we want to display seminars that deal with that topic. We have news posts that discuss content elements, or we might, you know, reference books and seminars, whatever. So at that stage, we already don't know the graph structure anymore. And finally, if we start offering individual bundling to our customers in a way that every customer is able to, you know, just pick the things he wants and put that into his shopping cart, then essentially we have to deal with we will have to deal with a graph structure that is really, really huge and needs an effective store to manage that. So this will hopefully enable us to answer questions fast, hopefully in real time, like display all seminars that discuss this wide neuroleadership book, or it'll allow us to do cross-references between content more easily. Our business people think about building linked data applications, and guess what? We'll use RDF and Spartan 1.1 for setting this up. Okay, let me just. So, and then we started about thinking about this, because how can we build such a system? And the first version idea was, okay, we could do this ourselves. And Haufe actually has 150 developers. We've built search engines ourselves. We have built content databases ourselves. We have eventually built object relational mappers ourselves. So why should we build this ourselves? And as being a software architect, I think it's just takes too long, of course, too risky and too expensive to build, even if you use Scala for that. And so that's why we crossed that out for sure. But we have other options. So the first thing we thought about was, okay, why not go, you know, there's great open source technology out there, and use something like JCR or Fedora Commons and use that as basic building block. And I'd not say that this wouldn't work, but we're not sure about if this scales. We're also not sure how XML agnostic they are. So we're certainly sure that we could use something like JCR, plug on something on top so that we have XPath and XQuery capability, but we're not sure if this is the right way to go. So we don't follow that approach. So I personally come from the domain of distributed systems. I said, okay, well, there's so much great stuff out there. Let's just take Elasticsearch. This scales like hell. And we just take some triple store library, and then we take some Hadoop file system and put the documents there. And yes, this would work, but we have a problem, and that's data integrity. Because we certainly want to avoid that if we import a product, and product in our case is at most, I think, 500,000 documents, and if you import a product with 500,000 documents, XML documents, and that import goes wrong, and you just have imported half a document, half a product in Elasticsearch, you cannot roll that back. So that actually raises the problem of data integrity, and that's why we, abstain from this solution, although it would be possible. Instead, we have decided to use an XML-based integrated solution. So you can probably guess which technology this will be. And because we also don't want to reinvent the wheel, that's what we had in the last discussion. And we want to, because we are really a publishing house, we want to focus on developing add-on functionalities. And there are also downsides with this approach, and that are license fees and the dependency on one particular vendor. You can probably, the name you should not name or so. And yeah, let me quickly tell you where we are to put you in the picture on the ongoing process of this. And I still got the umbrella. So in 2013, in fact, business people approached us like, "Hey, techies, could you build something? Because we want this." And we said, "Oh, of course. We will look into this global content search and we'll look into this unified content hub." I have 10 minutes left. Oh my goodness, I can speak forever. So, and they were like, "Okay, please, can you, create concepts?" And so we wrote really like literally 40-page abstracts about how you could build this. And it was actually, I think, 3 software architects have been working on that. And we were like, I remember these discussions with Christoph and Yannick. I was freshly in the company. I was like, "You want to do a search without access to documents? Really? Do you really want to store documents, but you want to, index them twice?" And we said, well, this does not make sense. So what happened was that we actually advised the company to consolidate those and, create this one huge big project. And so what happened in the winter was that we consolidated the draft and created this vision of the unified content hub, which now is done. But then we started about, okay, implementation issues. We looked into technologies because we don't want to just create paper, we want to create a working system. And so that's why in spring 2014 we did this proof of concept with the major NoSQL vendors, whose name I don't know, and which sits in first row. And we hopefully will start in summer 2014 to build this. And we believe that the technology we're choosing is really a good building block for us as a publisher, because we're not, we have been building a technology a lot in the past, but if you look at servers, at complex server applications, no matter if it's Elasticsearch, MarkLogic, on all these things, they're so complex and they easily outgrow the capabilities of a smaller company like we are, and that's why we have actually decided to, more shift our publishing toolchain more towards like developing add-on functionality, but not build a database sort of ourselves. Let me quickly summarize. So the driving force behind this endeavor is that we have this strong saturated content infrastructure, which really makes processes slow. We have components we have components, we have systems in the house. Basically, nobody does know anymore because all the developers who built those have left. And together with this problems of duplicated indexing, with the need of reducing infrastructure costs, we've decided that creating this unified solution is probably the right way to go. What I want to emphasize once more is that really indexing XML structures vital for us, because we have metadata, we use for faceted search, we have author information, and that's all scattered over the XML files we have. And we really need XPath and XQuery to make these, to enable search applications to our customers that are, convenient enough and fulfill their requirements. We've discovered triple source to be really, really a promising technology for our project. We've done first tests with MarkLogic. Guess this is the technology, and this really looks good, and it gives us actually the structural modeling flexibility we need. And what's important maybe here is that we will certainly need Sparkle 1.1 for dealing with the graph, because As I've said, we have graphs with arbitrarily complex depth. So, and we will need stuff like property path for graph traversal. We're working currently towards the first implementation, and we hope to share with you results from a working prototype next year. Thank you.
Thank you, Elias. We have time for questions. Yes?
Well, first of all, just to share an experience from
Yeah.
other publishing companies at the Oxford University Press, we do have similar issues, challenges, call them as basically unifying content from different sources, legacy data and so on, so you're not alone in this. I don't know if this can help or not.
We certainly want to talk to you.
Same here. I'm also sort of working for Pearson and similar endeavors in publishing. So I think it's a common pattern that whenever you have your content in XML, you want to do some modeling in RDF. So maybe we should have a group for that, where we use RDF, XML. That's the sort of.
That'd be really awesome.
Yeah. All right.
My question, actually, two questions. First of all, you mentioned cross-references and metadata, and then you showed us this content storage, search, and people store. I wonder, where do you store the cross-references and the metadata? Is it in the content storage, in the tuple store, on both?
To be honest, that yet has to be decided. I think my personal opinion on that, and I didn't discuss that with Christoph so far, so I might be totally wrong, is that I say any structure that that belongs to contents of the same group, that should be in the documents. But if you have references to outside entities, you might store that externally. But it's certainly a design decision we have to tackle. I have no clear yes or either that way or that way answer to this. What's your opinion on that?
Well, that's a good question as well. Because, I mean, if it is metadata or if it is, I mean, it depends on the cross-references, if they're linking different products or if they are linked inside the same products. You could have sort of a duplication of this,
right.
But then, you know, what do you do with this duplication? And actually, this comes into my second question, which is about unique identifiers. When you've got basically a piece of data from different products that is already sort of duplicated, how do you unify this in a
we have that,
way, which is also possibly human readable?
Let me show you something. We have unifiers at Helper Group, and those are called HIs. I spared that for you, but those are 1, 2, 3, 4, 5, 6 .xml. And the good news is this actually is globally unique. You will only find this XML file. If it's in the document, it'll always be the same content. But this is the good news. So we have this naming scheme. Haufen has its own naming scheme. We have similar one for link IDs, which would be outlines, and so on. But the problem with that is this might be different in version 1.5. So we don't have the versioning information in this naming scheme. So we still have to even, rethink the way we manage naming and versions. And this is also part of this project. But we're not there yet.
Are those generated IDs?
What?
Are they generated IDs?
They are generated. Christoph.
Yes, the editorial system generates them kind of a serial number.
What about identifiers within the XML?
Excuse me?
What about, you're talking about identifiers of the file name, but I suspect Sandra was talking about identifiers of elements within the XML.
Well, this HI number that is used in the file name is also the identifier. So as a string, it's just used as an identifier.
And then it's got a suffix at the end for the element? Or?
No, in those cross-reference elements in the content, they target HI 1125.
Okay, so I have two questions. I lost track who's first. Let's go up there first.
Sorry,
There's three.
oh, sorry, was it which one? Just in a comment about where to put the metadata, you also have to think of what tool you're using. And in Mark Logic, for instance, one of the things is you're saying, do I put it with the document? Do I put it outside of it? well, every URI in MarkLogic, every document that you put in there, the URI has a properties fragment as well. Right. So in MarkLogic, it doesn't necessarily mean it's another place. You actually already have a place, so you can XML with whatever you want, as many different types, and you can still have normalized metadata, so to speak, still in the document, just sort of isolated. So this, so it also depends on the technology. In that case, it's not really separate. It's an option of really storing it with it, but not bastardizing your content itself.
So let's work this down. Yeah.
Yeah. So I have a question. Where would you store the structure of the product? I mean, I can imagine if you look at books, for example, you have a table of content that defines the structure of the entire book. So where would that information be stored?
So at present, because what I didn't tell you is that we don't have like a few documents which with distinctive borders. In fact, we have 900 products. Yep. We have 900 products and I think about 20 million documents. And there's a huge amount of dual, or let's say 50. So a document might be used in 50 different products. So this is why we have a lot of edges in that graph, and that's why I'd say that I would store this in the triple store. Maybe you'd have sort of course, you will have triples with certain prefixes, and you might have different triple indexes because you certainly don't want the entire graph inside maybe one triple store. We have to discuss that. But my personal view is that I put it in the triple store.
Okay.
Other questions?
And one last question.
Not actually a question, but a suggestion for your naming scheme. Just use URLs. It gives you all flexibility to address different words in one name, etc.
Right. This is actually what we'll do. We'll prefix, for instance, a date, or we'll prefix a version number for this, which would allow us to distinguish the same HIs with different versions.
Sorry, just a very quick question. Have you looked at the performance already?
What?
Have you looked at performance?
No. Why are you asking?
Because it's always a problem with RDF and maybe lots of XML. Especially if you're gonna search across the whole graph and you'll have varying depths of the graph. It does become slow sometimes. Especially if you want to type and get the results in real time and the query takes 5 seconds, then it's not good.
Let me briefly tell you an anecdote. We have done this proof of concept with MarkLogic, and what I asked them to do was to do a depth search starting at a different node in the graph, and it turned out that the performance of the query was not as fast as I expected it to be, but it certainly first it turned out to be an XQuery problem, and second, that's something of course we need to address. But I think that first of all, triples are modern triple stores. They boil down to in-memory index structures, and these are essentially in-memory databases. So if you don't get let's say the data structure wrong, and this is not our job, it's MarkLogic's job, and I hope they did a good job with it. If the data structure is right, you'll essentially have an O.logn lookup if it's a tree or I don't know what structure is inside because they don't tell us. They should tell us, but but I think this is more or less an issue of the technology you're using for it. But I agree to you. We will make massive use of the triple store, and if it's not performant enough, this will break. But I hope it won't.
Thank you, Elias. So right now, time for us to take the last part of
Yeah.
Kannst du? Ich will nur mal Rechner bei Ihnen legen.